Hi and welcome back for another round of factoring quadratics. So in the last video we talked about factoring special quadratics, x squared minus 9, 3x squared minus 300, which are forms of difference of squares, okay? And we talked about how if you have something in common to the two terms, that you take out what's common first, and then you factor according to the difference of squares pattern, which is this. So here it is in its general form, a squared minus b squared, or in its universal form, and it factors according to that pattern, okay? Today I want to look at a different sort of difference of squares, and this one looks a bit odd. And it's that there. So when we get a little deeper into some of these math concepts, we start to use things that are called substitutions, and they make our work a little bit easier. It's not necessary to use substitutions here, but if you're in a high school math class or in a beginning algebra class, they're going to want you to use substitutions. Okay, again, you don't have to for a lot of these questions, but it does make your job easier and they do expect it. So we make what's called a substitution statement, and we say let x plus 2 equal, let's use a. Whatever you substitute, whatever variable you decide to use as substitution, can't be the same as the variable that you've already got in the question. So I can't say let x plus 2 equal x. Okay, that won't work. So then I rewrite this, putting my substitution in place. So x plus 2 was being squared. And if x plus 2 is now a, then a is being squared. Okay? So this makes it really simple to factor. It's simply a minus 3, a plus 3. But our original question was in terms of x, not in terms of a. So what I have to do now is put the x plus 2 back in for a. So I do this. I go x plus 2 minus 3 and x plus 2 plus 3. Then I combine the like terms here and end up with that. So this is the correct factored form of this. Now let me show you how it works if you do it the long way, because it does work doing it the long way. So if we do it the long way, we have to square x plus 2. So this entire binomial gets squared. So x plus 2 squared means x plus 2 times x plus 2 and then minus 9. BEDMAS rules say that I must do my multiplication before I do my addition or subtraction. So I have to multiply this out. So we get x squared using the FOIL method, first terms, outside terms, inside terms, last terms, and I can tuck the minus 9 behind there. And then combining my like terms, I get that. And then this is of the form that we've been factoring for the last several videos. So, don't know if I'm running out of room here on the screen, so I'll move this over here. What multiplies to make 5? That adds to make 4. Well, 1 and 5 only has one pair of factors, and that's 1 and 5. The 5 has to have a plus, the 1 has to have a minus in order to get positive 4. And when I multiply those two signs, I'm getting this sign, yeah? So that means that that is the correct factoring. Oopsie. That is the correct factoring for that trinomial. And notice it's exactly what we have here. Okay, so it's always going to work out to the same thing as long as, you've done the math correctly. If it doesn't, you've made a mistake somewhere, that has to work out to the same thing. Okay? And we'll do one more like that, and we'll show it to you both ways so that you see that it works both ways. So we have m plus 1 all squared minus m plus 2 all squared. Now again, we've got difference of squares. We've got two elements that are being squared, and just because they're binomial doesn't mean that it's different somehow. So all we're going to do is we're going to say let m plus 1 equal a, and we'll let m plus 2 equal b. And then we're going to just replace with our substitution statements, okay? And now we factor this, we get a minus b, a plus b. And now we have something that we need to be very careful of doing here. So we need to put the n plus 1 and the n plus 2 back in for a and for b. When I do that, I need two sets of brackets because the minus sign here, so first of all, the n plus 1 is the a, so we're going to put out that. We're going to put the n plus 1 for a. Then the n plus 2 is what b is, but it's all of n plus 2 that has to get subtracted. So that means we need a second set of brackets around it, okay? So this here is my a minus b. There's my a, and there's minus b. Now I could put this in brackets too, but it's not necessary, okay? And then my second one I won't need any brackets because, second set of brackets, because the second term is positive. So because I have a plus here in the next one, I don't need a second set of brackets. I could put them in, but they're not necessary. So we're just going to put n plus 1 plus n plus 2. Okay, and then if I did put brackets there, it would make no difference. Okay, now for this set here, I'm going to drop one set of brackets, the outside one. So m plus 1 minus m minus 2. That minus is getting multiplied to both terms. Bracket. And this one, we have m plus 1 plus m plus 2. You see how those inside brackets made no difference at all. Then here we have m, no, the m's go away, don't they? See that? We have m minus m, and they go away. So here we end up with negative 1. And here we end up with m plus 2m, sorry. We end up with m plus m, which is 2m, plus 3. And then you could write your final answer simply as negative 2m plus 3. You need those brackets around there. Okay, that's messy. Hold on. Let me rewrite that for you. So negative bracket 2m plus 3 is what we end up with. Now, is this a surprising answer? A little bit, isn't it? I mean, we expect, because we have difference of squares, that we're going to end up with, you know, something like that, but we haven't ended up with that. So let's see why that happened. I'm going to multiply this out over here and do it sort of the long way. Now, we haven't done a lot of polynomial work in terms of multiplying out. It's going to be the subject of further videos. But whenever you've got a minus sign, whatever comes behind it needs to be bracketed fully simplified, and then at the end you bring that minus through. Otherwise, you make mistakes. So here we get m squared plus 1m plus 1m plus 1 minus bracket m squared plus 2m plus 2m plus 4. Okay, I'm going to bring these two terms together. So here I'm going to go m squared plus 4m plus 4. And then I'm going to multiply through this negative 1, and that's how I'm going to get rid of these brackets. Minus m squared minus 4m minus 4. Now my like terms, m squared minus m squared, that's why they're gone. See that we don't have a squared anymore. We've only got one m when we're done. Then I've got plus 2m here, minus 4m here, which gives us negative 2m. Okay, 2 minus 4 is negative 2. And here we get minus 4 plus 1 is minus 3. Now anything with a leading negative, as I've talked about previously, is a little bit hard to deal with. I call them stinky. Okay, they're not easy to work with. So it's always a good idea to factor out a leading negative, even if it just leaves you with nothing that looks particularly better. It's just easier to have something that does not have a leading negative. Also, it helps to notice when something can be factored. Even if you don't have to factor it, it's good to know that it can be. So notice, same thing that we're getting here that we have here. Okay, so that's it for that for today. Short video. If you like this video, please give me a thumbs up and please subscribe to this channel so that you can see more of them and learn lots of math. Okay, thanks very much. Until next time.